So dear students, after a long time I'm posting this video for the next class, and today's class will be on drift velocity of electrons. So we are doing our third chapter, that is current, electricity, current electricity. So under current electricity, so our topic for today will be drift velocity of electrons. Drift velocity of electrons. So drift velocity is, write it down, drift velocity is the average velocity that an electron gains in the presence of electric field. So when you place an electron in an electric field, then it gains an average velocity. That average velocity is known as the drift velocity of the electrons. Now, without electric field, if you have a metal like this, now without the presence of electric field, how electrons move? First we need to see that. So suppose I have an electron. So without the presence of electric field, this electron will have a random thermal motion. This electron will have random thermal motion like this. This electron will come here, it collided with an atom. This is an atom, so it collided with an atom and it goes like this, and again it collided with some atom here and it comes back down. Again it collided with some atom, it goes like this. Again it collided with some atom and it goes like this. Again it collided with some atom, it goes like this. Again here it collided with some atom and it goes like this. Again it collided with some atom and it goes like this. So this motion is random. We call it random thermal motion. So without the presence of electric field, an electron will have a random thermal motion. Now so the trajectory of electron moving in a metal would be like this. Suppose this is an electron, so it moves like this, here to here, and here to here, 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 here to here. So it's random, it's totally random. The trajectory is totally random when there is no electric field. So an electron moves in a random thermal motion. But when you place this electron, in an electric field, suppose this is an electric field going towards this direction. This is an electric field going towards this direction. So this is an electric field going towards this direction. So when you place this electron in an electric field, so its trajectory will be affected. How it is affected? Suppose an electron will have a random thermal motion like this. Suppose it has a random thermal motion like this. Now what will happen? If this is the random thermal motion of electron, now in the presence of electric field, what will happen? The electron will move a slighter against the field. If this is field, so now the electron will move slightly against the electric field. Then its trajectory will be like this. Earlier its trajectory was this. But in the presence of electric field, the whole trajectory will move or shifted towards the right side of the electric field, because electron always moves against the electric field. So this is the direction of the field. So if this was its original trajectory, so the trajectory itself will be shifted a bit towards or a bit against the electric field this way. So the new trajectory will be like this. Suppose this is an electron moving in random direction, random thermal motion. Suppose this was an electron moving in random thermal motion. These are the points where the electron collide with atom. So in the presence of electric field, its whole, if this is the direction of the field, its whole trajectory will be shifted against the field a little bit towards the right side. The whole trajectory will be shifted a bit towards this one. And this velocity, this velocity with which its trajectory is being shifted towards the right, the velocity with which its trajectory is shifted towards the right is known as the drift velocity of electrons. So in this subsection we are going to derive the relation for drift velocity. Now suppose this is the trajectory of an electron. It collides with atom, it goes like this. It collides with atom, again it comes like this. It collides with atom, it goes like this. It collides with atom, again it comes like this. It collides with atom. So suppose this is some electric field here. Now suppose when an electron initially collides with an atom, then it changes its trajectory and it moves towards this direction. So let V initial will be the velocity of electron after the first collision. Initially, after the first collision, when electron collide with this atom, then it moves towards this direction. So initially when it starts to move towards this direction, let its velocity be Vi. Okay. Now then when it collides with another atom, its final velocity be, let it be Vd, drift velocity. Its final, let us say its final velocity will be Vf, V final. So this V final and this V initial are related by the kinematic equation. V final is equals to V initial plus acceleration into time. So this is our relation. V final is equals to V initial plus acceleration into time. So in this case, V final velocity will be equals to V initial. Now what is the acceleration of this electron in this electric field? So in an electric field, an An electron will experience a force of minus E into E. Okay, this is the force experienced by the electron in the presence of electric field.